Hi, it's Mrs. Scarple, and in this video we're going to be looking at the OR compound inequality. Mrs. Bierman in her video went over the AND compound inequality. So just a reminder that a compound inequality is an inequality formed by joining two inequalities with the word AND or the word OR. And in this video we're going to focus on the ones with OR. So the compound or the graph of a compound inequality with OR is what we call a union of the graphs, meaning that we include all of the possible values for both inequalities. So it's either one inequality or it's the other. So for example, in this situation, we're taking y is less than or equal to -2, and we're taking the inequality y is greater than 1, and we're combining them into one compound inequality, and we show both graphs. We show the graph for each of them. Because it is an OR, in order for it to be a solution, it has to be a solution for at least one of them. It does not need to be a solution for both. It needs to be a solution for at least one of them. It's a solution for one or the other, hence the word OR. So let's take a look at how this works. We're going to write each sentence as an inequality, and then we're going to graph it. So we have a number t is less than -1. So t is less than -1, or, so I'm going to write the word or, greater than or equal to, so we still have that number t, greater than or equal to 4. So we have two inequalities that are happening in that one sentence. When I graph it, I have -1, I have +4, and I graph each inequality separately. So at -1, we're not including, so that's going to be an open circle. And because we're looking at values that are smaller than -1, we want an arrow to the left. For t is greater than or equal to 4, because it is equal to, because of that bar underneath, we do want to include the 4, so we're going to fill in that circle. And because t is representing all numbers that are bigger or greater than 4, we want an arrow to the right. Now, something that I sometimes associate with OR is when I draw my arrows like this, it kind of looks like oars on a boat. You know those paddles that help you row a boat? Oars on a boat go with OR. I'm only mentioning that because in an upcoming video we'll be talking about absolute value inequalities, and I'll be making a similar reference. Let's take a look at the next example. A number A is fewer than. Remember, fewer than is less than -6, or no less than. So no less than means it could be more than, but it could also be equal to -3. So we have A is less than -6, or A will be greater than or equal to -3. So -6 is a smaller number, needs to be on the left of my number line. -3 is to the right on my number line. We are not including the -6. I do not have the equal to, so that's an open circle. And A is representing all numbers that are smaller than -6. So we have an arrow to the left. Then we have A is greater than or equal to, so that equal to indicates that we need to have a solid or filled in circle. And A is representing all numbers that are bigger than -3, so we want an arrow to the right. So that's generally how we see graphs of compound inequalities that are OR. I do want to let you know that it is possible for OR compound inequalities to overlap. They could both be less than, they could both be greater than. So it is possible for them to have some overlap. We can also solve compound inequalities. So we have two inequality statements here that we need to solve. We follow the same steps for solving any inequality. It's just that we're going to solve two inequalities and we're going to graph the solution for both of them on the same number line. So for 2x minus 6 less than negative 2, we start by subtracting the 6, just like we would with any solving. So 2x will be less than negative 8. And then to get x by itself, to isolate the x, I divide both sides by 2. And because I'm dividing by a positive, I'm not going to do anything with that inequality. That inequality stays the way it is. I'm dividing by a positive number. So we have x is less than negative 4, or I also have to solve the second inequality. Add 5 to both sides. And we have 4x is greater than 8. Divide both sides by 4. And we have x is greater than 2. So now I'm going to put those numbers on my number line. Negative 4 is the smaller number, so that needs to go on the left. 2 is the bigger number, so that needs to go on the right. I do not have an equal to on either of these, so when I graph, I have an open circle for both of them. X is representing all the numbers smaller than negative 4, so I have an arrow to the left because that's all numbers smaller than negative 4, but x is also all numbers bigger than 2, so that's an arrow to the right. And that is the solution with its graph for this compound inequality. Now here is your turn to try one. Solve the compound inequality and graph its solution. Now that you've had an opportunity to solve it yourself, let's see how you did. Hopefully you subtracted 1 from each side, and you have 2p is less than negative 8, divided both sides by 2. And p is less than negative 4. And on the other one, we would subtract by 3. Now keep in mind that's going to be a negative 2p yet. That negative in front of the 2 doesn't disappear. Is less than or equal to negative 4. And I'm going to divide by a negative in this case, so hopefully you remembered that when you divide by a negative, that inequality also makes a change. That inequality also flips around. And we have positive 2 when we divide the two negatives. So on the number line, negative 4 should be on the left, positive 2 on the right. Negative 4 is not included. We don't have an equal to, so that's going to be an open circle. And p is representing all numbers smaller than negative 4. So we will have an arrow to the left of that. And then for 2, it is equal to, p is greater than or equal to, so we need to fill in that circle. We need a solid circle. And p is representing all numbers greater than or more than 2, so we need an arrow to the right. So that is how we will solve compound inequalities that are of the OR variety of compound inequality.